Hi everyone, I'm back with another very nerdy video. I'm going to show you this book. It's a beautiful old-timey book about astronomy. So it was published in 2022 as Phaenomena by Thames and Hudson, but it's a reprint of this very old book called Celestial Atlas by Doppelmayr. So I'll show you what the book itself looks like, this one, and tell you a little bit about the book, the original one. And then, of course, show you some of the beautiful illustrations and diagrams. So the original book was a series of plates or diagrams, artwork about astronomy that was printed in the 1800s. There's a foreword by the Astronomer Royal, which is an actual job apparently. And then there's an introduction explaining a little bit about Doppelmayr, who was an artist and printer, and where he worked in Nuremberg, which was an extremely lively and exciting place to be if you were publishing books and doing astronomy. So this was the original book, right? So obviously it was entirely written in Latin and published in Latin. Atlas Coelestis, Unquamundo Spectabilis, etc., etc. Even the names of the people are all Latinized, right? Copernicus is already the Latinization of his name, and his name is written as Doppelmayr, Norimbergai, which means Nuremberg. By this point, Copernicus and heliocentrism, with the sun in the center, this was considered established by astronomers. But you have to remember that astronomy was also not very useful at the time. So even if something had been proven to be right, people just shrugged and said, I guess that's nice to know. So this is the actual table of contents. The original book were 30 plates, which is what they called these big engravings. So they had to hand engrave this in metal and then print as an entire page. Of course, the text itself was movable type. These books at the time, they would have been printed in black and white, and they were not exactly useful books, precisely because, as you can see, they will mix a bunch of different competing theories together. The whole point is to look nice. And then you could invest a bit more and then buy one of the colored editions. So they were hand painted in color if you wanted. So I want to start by showing you the map, which is probably the one that looks the simplest, but it's actually the most interesting and dense. Page 134, let's go there. So here we have it. It's a map of the world. So what is this doing in an astronomy book? Well, as I said, everything is in Latin. So it says Basis Geographiae Recentioris Astronomica. And then we have some information about it. So that's what's cool about this book, is that it will explain to you what that plate means with reference to other stuff that was being produced and discovered at the time. So they translated for us astronomical basis of modern geography. So you have to remember that this was before GPS, and making maps was extremely difficult. There were other ways of doing that, non-astronomical ways, let's say, when you sail across land. But these are only astronomically determined positions on the planet. So if I zoom in a bit, you might see that there are towns and places, right? And many more in Europe, as you can see. And all these spaces are listed here in the bottom and at the top. And they were determined astronomically in relation to eclipses. Because the Earth spins and spins in a regular motion, the time it takes for an eclipse to be visible from one place to the other tells you how many degrees in longitude you are from that place, because the Earth spins in a gradual and smooth way. So every 15 degrees of the circle is 1 hour. So if you are here or here or here, and if you calculate your local solar noon precisely, and then you calculate how many hours after noon you saw a lunar eclipse, and then you just meet your friend later and see what time he was there. And by knowing, the time difference between places, they could determine the positions. Because a lunar eclipse occurs in the moon itself, the moon actually becomes pink. So this is something immediate that everyone on the night side can see at the same time. So it's interesting to see some of the places where they got. So they list several different places. So we have Hispania, Portugalia, Gallia, which is how they write France. There are all these different places in France. Most of the town names are also written in Latin. And then at the bottom we have Germany, Germania, Belgium, and then we have Anglia, England, and then it says in Latin Londinium, and it says the name of the people who observed, and this is the longitude and latitude that they calculated. And in here the symbols are what kind of eclipse they saw. So there's a sun symbol for a solar eclipse, the moon symbol for the lunar eclipse, and the Jupiter symbol for when they see an eclipse of one of the moons of Jupiter. And this was actually quite useful because it happened a lot. There are many moons of Jupiter, so they created very detailed maps of Europe at the time. We also have Edinburgh in Scotland and Dublin in Ireland. And then here at the very corner, we have America, Americae. And then we have, for example, Boston right here in the United States. And then we have Olinda in Brazil, which is right here where they have the coast. And if you know the coast of Brazil, this looks unnatural. So the rest of the coast of Brazil is actually closer to this line. So they had the Olinda position right, but not the rest of Brazil. And obviously in Europe, things were much, much more detailed. And they had all these observations. But further, they didn't know what's behind, like besides Australia or beyond. The top of North America is also unknown. And of course, there is no Antarctica. And then we can also say something about the artwork, of course. So the artwork here shows the different astronomical events that they used to draw this map. This is the solar eclipse. This is the lunar eclipse. This is the shadow of the Earth covering the moon. And this represents the eclipse of the moons of Jupiter. And here we have artwork of people observing these astronomical events with different instruments. So what this book does is not only gives you the original plate, it also zooms in and shows you in more detail, for example, showing how it shows the moons of Jupiter. being eclipsed. The other kind of plate that's also included in this book will probably come across as more scientific for us nowadays. And it's information about the moon. Of course, everything in the moon was more accessible because the moon is the largest thing in the sky, and the markings on the moon are visible to the naked eye. And with a simple telescope like the one Galileo had, like 100 years before this, he could already see a lot of these details. So this feels closer to what we know as astronomy. One thing here that it's a bit misleading is that when you see these two kinds, these two hemispheres in a diagram like that, they usually are showing, for example, the two hemispheres of the Earth or North and South Pole. But it's not. If you take a look, they are exactly the same markings. So these are two different maps of the same place, the near side of the moon, which is the only one we can see from the Earth. So these are just two different maps of the same place by different authors, and it mentions their name right here. And I don't know why they decided to write Riccioli as the bigger name, but it is indeed Riccioli's names that stuck with us. So the Sea of Tranquility and terms like that. But I really love the way they show the details. So here it's just showing how they knew that the moon was a terrain because of the way the shadows behave on the moon. So here's explaining that the same crater on the moon, depending from which angle the sun is coming, from this side or from that side, it would cast different shadows. And of course, if it's aligned with the sun, if the sun is striking it head on, you probably wouldn't be able to see, which explains the lighter parts of the moon, right? So some of these shapes you can only see along the terminator. I know this is a funny name, but this is what the terminator is. It's the border, it's the line between the light side and the dark side. Well, not side, I'd say the illuminated and non-illuminated part. With a telescope or even with the binoculars, you can see how jagged it is. And the reason it's jagged is because the moon has terrain. Some parts are higher than others. This was quite groundbreaking when Galileo found that. And I think there's actually one of his drawings here. So these are some of Galileo's drawings. So he didn't invent this telescope, but it was quite a new thing. And then he pointed it at the moon. And then he did these drawings of what he saw, and that the moon was a terrain, and the border between the light and the dark was jagged. He was quite struck by that, especially because, like this, sometimes you have a line, or here there are bits of bright on the dark side of the line. And the only reason this would happen is if this is a mountain. So imagine you're here, the sun is at the horizon, setting, but then some of the mountains are still illuminated, and if you were at the top of the mountain, you would be higher and you would still be able to see the sun, right? So this is what was happening, and it was quite shocking. A lot of people didn't think that things in the sky, like the moon or the sun, were actually made of rocks and ground and matter. They thought they were maybe a completely perfect, smooth surface like glass. They had no way to know. The other kind of diagram that we get in this book a lot are these geometric plates. And I find them fascinating, and especially because the history of astronomy has included so much of diagrams like this and simple geometry. you also have to remember that this is not how brand new astronomy was published at the time. So brand new suggestions in astronomy, like Copernicus and all that, they were published in prose, usually in Latin. At this point already, people were starting to publish things in their own language, but you might include some simple diagrams, but your proposals were published in text. So this is not a scientific instrument, this book. It was quite useful. You could get a lot of information from it, but it was mostly something for the uh, well-heeled aristocrat. So what it's showing here is it says motus in coele spirales. So it's the motions in the sky that are spiral motions in the sky. So spiral motions in the heavens. As I will show you in a different diagram, they already believed in our current heliocentric uh, belief that the planets all orbit the sun, including the Earth. Actually, the Earth was a planet was actually a title of a book because it's an argument that had to be made. Here is just make believe. So this is what things look like and what people have tried to explain as. A lot of this time, it didn't really matter what was happening in the sky as long as you could predict it. So if you wanted to invent a bunch of spirals that don't exist in nature but that make your math work, that was fine actually, and people didn't care. So what this shows is imagining the Earth in the center, right? And then you have this yellow line which says orbita solis. So this is the orbit of the sun around the Earth, right? And it's basically a circle, right? This is not the motion of the day. This does not represent daytime and nighttime, daytime and nighttime. No. What the movement that makes daytime and nighttime is the sky itself. So the entire sky moves around the Earth. That's what makes nighttime and daytime. The sun by itself moves the other way very slowly and does this in 1 year. That's what they believed. And if you see, there are dates here. So 7th of December, 14th of December. So this is where the sun would be around the Earth, if this were true, which is not. In that case, then the planets would have to make some very funny shapes. And I think people just enjoy the shapes. But these are also dates, so these are real observations. And it actually says the name of the people who took these observations and where they were. It's very detailed. But because we know, for example, this blue line is the motion of Mercury. So obviously we know now that Mercury is going around the sun. So if the sun is going here, right, Mercury is going wee, so it looks like it does a loop-de-loop for us. Obviously, they didn't actually say that the planet was going like this in this path because they believed everything moved in a circular motion. This was absurd, so they didn't think this happened. They explain it like this. Let me show you here. It's circular motions inside circular motions. And luckily we get zoom in here, right? So what they believed is that there was a circle, or a sphere more precisely, that was going in orbit of the Earth along this line. On this sphere was the planet Mercury, and this sphere itself rotated so that this is the pathway that Mercury would do. And these were called epicycles. And that was the only way to make astronomy make sense with observations, precisely because they were assuming the Earth was in the center, right? So this is what happens when we say that in astrology, when Mercury or Mars is in retrograde, when it's moving, for example, from right to left, and then whoops, now it's moving left to right. So this is what retrograde means. I like this diagram because it's very geometric and it looks so cute, but is also very scientific because we have the dates of observations, and these are specific maps, let's say, in a different perspective because we are looking down onto the solar system, right? And this is a map of the movement of the planet against the sky, right? So let me show you. So here it says that it's the uh, movement of Venus, Veneris, Mercury, so Mercury, and it says the year there. So this was in 1712, right? And then it shows specific dates, and then there are numbers so you could locate this in a map of the sky, right? And there are the astrological signs as well, right? So Leo. So the planet was in Leo, right? Some of the earlier plates, so this is the beginning of the book, they're actually simpler and they deal with like more basic facts about the universe. So this one is literally just called Phaenomena, which obviously had a more specific meaning when used in scientific Latin like this, but it name drops Copernicus right in the beginning. So it's centralizing Copernicus' model for us to explain how the seasons work. So this is explaining the different length of the day depending on the time of the year. And that's why we have this artwork here. So this artwork shows the sun, right? Helios, the god of the sun, being pulled. He has a chariot, and then he brings the sun every day. And then he's pulled by these magical horses or whatever. I think Dawn is one of the mythological characters as well. And here is the moon hiding away. You know, you can see there she has a little crown, which is a crescent shape. Um, so here it explains with very simple to us heliocentric science how the seasons work. So here you have the Earth, and the Earth is tilted with respect to the Sun. And then these three lines that we see on Earth is the equator, the Tropic of Cancer in the north, which almost seems to cut Florida there, right? Even though it doesn't. And here we have the Tropic of Capricorn in the south, which crosses São Paulo in Brazil. So in this moment of the orbit, it's summer here in the southern hemisphere, but it's winter here in the northern hemisphere. Because of the tilt, there's more light, and these lines are supposed to show you geometrically where the light will hit with a right angle, which is in the Tropic of Capricorn, and that's why it's called that. And the reason it's called the Tropic of Capricorn, and I hope you can see that, is because of where the sun is. So if the planet is here, if we are here, and the sun is here, when we look at the sky, which of course we can't, we would see the constellation of Capricorn, and this little symbol here is the symbol of Capricorn. And the other way around works the same way. Here we have the Earth is on the other side of the Sun, but still with the same tilt. Now the northern part of the world is pointing towards the Sun. Now it's the Tropic of Cancer that is at a right angle with the Sun. This will be the summer solstice in the northern hemisphere. And then the Sun will appear to be in Cancer. It's such a tiny symbol. Yes, but you see this is Gemini, and you have the other symbols there. Again, because we position the Sun against the background of the stars. Of course, we cannot see the Sun. against the background of the stars, because we can only see the sun during the day, and during the day there are no stars, right? So we can only see this half of the sky at night when we are on this side, and then we can see these constellations. But because we can see these, we know which 6 constellations are on this side, and we know that the sun is here where Cancer is, even though we cannot see Cancer. And that's what it means, right? To be a Cancer, have the astrological sign of Cancer, is because this is where the sun was. It's a apparent location. Around the Copernicus system, we have these other systems, and some of them are very, very old. So this one is the Ptolemy system. He was a 2nd century of the Common Era astronomer in Alexandria, and he established a lot of what most of the West, and we should say Eurasia actually, knew about this. A lot of these ideas he got from Babylonia and from Babylonian astrology, and then a lot of his science and his writing was only preserved in Asia for a long time, and then it was retranslated into Latin and all that. And then we have Plutarch. So sometimes the order, like the fact that the Earth is in the center, the Earth is also in the center in this one. The differences are small. There are just some details that explain why some things happen, and they have labels. Some of them are sort of heliocentric and the sun is in the center, but there are other wrong things. And as you can see, there's a lot of text. This one is not one of Doppelmayr's plate. It's just something that this book decided to bring for context. So the book brings a lot of the context in the predecessors of this kind of book, I guess. So these are the 2 hemispheres of the sky, represented as maps of the northern and the southern celestial hemisphere. This is Dürer, so it's 1515. So this is the very beginning of the 16th century. So much, much earlier, like 200 years before Doppelmayr, and the very beginning of what we, know as the discoveries of colonialism. So they knew a lot about the northern hemisphere, right? So uh, here they decided to separate the the hemispheres. Instead of separating at the equator, they're separating at the ecliptic. So for example, Scorpio here is almost out of the frame because Scorpio is a very southern constellation. It would actually make more sense to include it on this side. But they decided to use the zodiac as the border here. And then we have Ursa Major, Ursa Minor right here in close to Polaris. And then here we have the southern hemisphere, and there's almost nothing there. And the reason for that is because they didn't know. They hadn't been there, so they couldn't draw what they saw. Um, and they put all the zodiac constellations here. Um, but some of the new, so Orion ends up, which is a constellation that's visible almost everywhere, but it's south of the ecliptic, so that's why it's a part of this half. But the Rio celestial equator goes almost exactly at the belt of Orion. That's why it's such a prominent constellation for almost everyone. And then we have Centaurus here, which is one of my favorite constellations, which is a southern constellation. And it used to be visible from Alexandria in northern Egypt on the Mediterranean at the time of Ptolemy, so 200 AD. But then it stopped being visible, and a lot of these things they had never seen. So they had from Ptolemy, from Arabic translations of Ptolemy, a map of the sky, not drawn like this, but as a list of stars, in their coordinates, so you could put together a constellation like Centaurus and put it there. But there's something very important missing from Centaurus here that we know now, especially if you have been to the southern hemisphere. So this is a more up-to-date map of the southern celestial hemisphere. Again, this one is also using the ecliptic as the border, so that's why these circles are not centered, right? So the southern pole is here, not here. As you can see, Scorpio is here, very far south. There are parts in northern Europe that it's very difficult to see Scorpio. And then Centaurus is here. Facing that way, we may explain that in a second. It's a very bright constellation, but here in between the legs of the Centaurus, we have the constellation Crux, which is the cross, which is called the Southern Cross, which is a very bright little constellation. It's the smallest constellation in the sky, but it's very useful because it points towards the South Pole, which is inside this circle, and there's nothing inside the circle, so the circle is not useful. So there you go. You have the Southern Cross. So this is a Christian interpretation of these stars, of course. Here we see another representation of Centaurus, the constellation. This is also a map of the southern hemisphere of the sky, but now using a different projection. But also crucially, this is what it actually looks like in the sky. So the previous one was mirrored because sometimes they would represent constellations as if they were being seen from outside of the sky. So everything is seen like this. So this is the real appearance in the sky. As you can see, the stars are actually labeled, so you can see exactly the names of the stars like this, and they're separated by constellations. A lot of these, it says where they're getting their coordinates from, if it's from Ptolemy or another astronomer. These two stars are extremely bright and quite beautiful. This one is quite famous at the very front paw of the Centaurus. This is Alpha Centauri, which is the closest star to the Sun, only 4 light years away. It's quite bright. So Centaurus kind of goes around the Southern Cross, which again is very easy to see and very bright. And also it never sets after a certain point in the Southern Hemisphere, just like Ursa Minor in the Northern Hemisphere. This will just go around the South Pole, always sort of pointing to the South Pole. It's not perfect, but it was useful enough. So I hope you have enjoyed this exploration of this very nerdy book that I've spent many hours reading and appreciating. It was not that expensive, actually. I thought this kind of book like this would be more expensive, but it's definitely worth it. It's a beautiful edition, and I learned a lot.